While we are still here, I would like to take the opportunity to explain the concept of endians. When we store 16-bit data in memory, it requires 2 bytes. As we know, 16 bits equals 2 bytes, since 8 bits is 1 byte. Most computers provide a unique address for each byte, and because of this, there are 2 approaches for storing data in memory. There is the little endian approach and the big endian approach. So let's say we want to store 16-bit data, that is to say 2 byte data in memory. We will need 2 addresses like we've established. So let's say we have one address 0x2000.608 and another one 0x200.0681. The dot here is just to make it readable. Yeah, we can clean it, but it makes it easy to look at the numbers. And yeah, as you can tell, we put in this in the RAM. Just a while ago when we showed the demarcations of memory, we said the RAM started from 0x2. So yeah, this is the RAM area. So we would have to put 1 byte. We would have to put 1 byte at one address and another byte in another address. So with the big endian, the most significant byte is stored at the lower address. This is rather opposite for the little endian, where the least significant byte is stored at the lower address. You might be wondering what's the most or least significant byte. Let's say we have this hexadecimal number 0x038A. In fact, there's the hexadecimal code for the decimal number 1000. The first 2 numbers, or the first 2 digits, gives us 1 byte, and the other 2 gives us another byte. This is the most significant byte. The leftmost byte is the most significant byte, and the rightmost byte is the least significant byte. So keep in mind, with a big endian, the most significant byte is stored at the lower address, and with a little endian, the least significant byte is stored at the lower address. So let's look at an example. Let's say we want to store the same value 0x03E8 in memory, and as we said, it's 1000. Let's say we want to place them in these addresses 0x2000.0680 and 0x2000.681. Let's say we want to put this here. As we can tell already, we know 0x03E8 a 16-bit number, which means we would require 2 bytes. If we wanted to place a 32-bit number in memory, we would require 4 bytes, because 32 divided by 8 gives us 4, and this is because 8-bit makes 1 byte. So let's just draw up a table here and try to place them. Let's say we have the big endian and the little endian, the same addresses. How would we do it in a big endian computer, and how would we do it in a little endian computer? With the big endian computer, we would have to put the 0x03 at the lower address. The 0x03 is the MSB, the most significant byte. We would have to put the other byte in the other address. If the number were to be a 32-bit number, we would have to follow in this order. With a little endian, it's the opposite. We have to put the least significant byte in the lower address, and the most significant byte in the rather higher address. So this is how data is placed in the big endian and the little endian computer. So this follows through in 32-bit numbers. Some microcontrollers come in big endian and others come in little endian. For instance, the microcontrollers made by the Freescale company are big endian microcontrollers, but keep in mind our CORTEX-M uses the little endian.